Okay, welcome everyone to our ETIP Ocean webinar focusing on off-grid applications of ocean energy. So ETIP Ocean is the European Technology and Innovation Platform for Ocean Energy that is managed by Ocean Energy Europe, and we are partnering here today with Technalia, who are part of the consortium taking care of ETIP Ocean and organizing these events that are aimed at sharing information, bringing the sector together, and identifying priorities for the development of the sector. So today we will talk about off-grid applications for ocean energy, which essentially is everything to do with non-large utility scale ocean energy applications. So we have today 3 examples of that kind of applications, and these can be either a market in themselves, or it could be a sort of a stepping stone for some companies towards the utility scale markets. But we will look more into detail of what those can look like today. So today we will start with an introduction by Pablo Ruiz-Minguera, Head of Wave Energy from Technalia, to give a bit of a background and explain where this webinar topic comes from. Then our panelists are Andrea Caio, Business Development Manager from Motion Energy, Michael Henriksen, the CEO of Wave Piston, and Brendan Cahill, Director of Development from ORPC. And I am Lotte Pirtimo, Senior Policy Officer at Ocean Energy Europe. With that, I will just hand it over to Pablo first, and we will get started then.
Screen. Screen. I think this should be okay. Hope that everyone can see my screen. Yeah, I will make a brief introduction to the topic of this webinar, but I'm sure that everyone is familiar with the Strategic Research and Innovation Agenda for Ocean Energy. This is a reference document for the whole ocean sector, which outlines priority research, development, and innovation challenges expected to deliver the greatest cost reduction. And this document defines specific objectives and actions towards ocean energy commercialization, and thus provides guidance to all funders of innovation, industry, the European Union, national and regional governments and funders. It was officially launched in 2020, and it covers basically the period between 2021 and 2025. Yeah, there is a link in the presentation to download, but you can access it through the ETIP Ocean website. The Strategic Research and Innovation Agenda is structured in challenge areas, which are research and innovation fields for the ocean energy sector that the ocean energy sector has identified the most worthy of investment during the period. But design and validation of ocean energy devices is considered the most urgent and crucial area, and other areas are to support this one. The projects are intended to contribute to expected impacts are described in the priority topics that belong to the challenge areas. And all the projects should demonstrate wider impacts on European Green Deal objectives. So the priority topics, where each challenge area is broken down, have a generic description, which include the scope, applicability, either wave, tidal, or other ocean energy technologies, the actions that could fit within this type of projects, the expected impacts, and the entry and exit technology readiness level. Also, the budget required in terms of number of projects and the size of these projects. In this slide, you can see the 6 6 challenge areas and the priority topics. The first one, as I said, is the most important one and has the greatest number of priority topics. Today, we are concentrated on the integration in the energy system, and more particularly into the development and demonstrated of near commercial applications of ocean energy. So the scope of this area, as Lotta introduced, seeks removing the remaining obstacles to industry-led growth of ocean energy and involves actions. Among them are the identification of the best applications for this first near commercial deployment, the validation of the value propositions relative to conventional alternatives, the demonstration of technology readiness and the near cost competitiveness for this selected application. And within this, offshore grid application represents both an alternative market itself and a stepping stone towards this greater, larger scale utility ocean energy. The expected impact of the actions here are the risk in commercial development of ocean energy, the acceleration of the path to technology LCOE reduction, and finally, also we seek within the project sharing lessons learned and experience, which is particularly the focus of this webinar. And with this, I will pass on to Lotta and the panelists that will share with you the experience.
Thank you, Pablo. And indeed, if the purpose of this is to share lessons learned, but also to start a conversation. So if you have any questions or you want to share your own experiences regarding the topic, don't hesitate to write them in the Q&A box, and we will take questions after the presentations. So our first speaker is Andrea Caio from Ocean Energy, and you will talk about a specific application on subsea infrastructure. So the floor is yours.
Thank you, Lotta. Thank you, Pablo. Just making sure I'm sharing the right screen. Is that coming through okay?
Yes, perfect.
Perfect. Great. So yeah, thanks very much. Thank you for the invite. I guess the first thing to say for those less familiar with Motion Energy is we are an ocean energy company focusing on developing wave energy technology, but also integrating it with other forms of offshore renewables and energy storage. So today, what I've been asked to talk to you about is within the context of off-grid applications, this RSP demonstrator, so renewables for subsea power. What is it? It's a net zero technology center flagship project. So it's a first of a kind commercial full-scale system that includes essentially a standalone microgrid offshore that is powered by a wave energy converter. So in this case, it's our Motion's Blue X wave energy converter, which is a 10 kilowatt rated device. And this is really a project led by Motion Energy as a wave energy developer, but also Volume, who are developing the subsea battery storage system, which is on the seabed. We're about 50-meter water depth off the east coast of Orkney. And then that in turn is feeding power to a subsea control module provided by Baker Hughes, who are a big technology integrator company, and an autonomous underwater vehicle dock with its AUV as well, provided by Transmark. So we've got a series of developers coming together, integrating their systems. We've got a technology integrator who is interested in these sort of electrified standalone solutions. And then we have potential customers who are contributing financially and via steering committee into the project. And these are big oil and gas companies. So Harbour Energy, Serica Energy, UK-based, PT2EP, the national Thai oil and gas company, and then two super majors, Total and Shell, that have come into the project at later stages. And so I think a key element of this is not really just proving out the TRL of the wave energy component, but really the whole full system TRL. And the other aims are really to boost industry confidence in this as a sort of self-contained solution to electrify off-grid systems, and also pave the way to wider decarbonisation, so scaling this system up in size and also number potentially. So just to give you a sense of the real sort of systems in the water, this was almost exactly a year ago. Sorry if the video is a bit laggy. We've got Blue X. You can see some small solar panels on top of the WEC. And these are helping to provide the hotel loads and the comms demand. And then the subsea skid is the yellow one, bottom left on the quayside. That contains the battery modules, the subsea control module, and you can see the AUV dock just clamped, bolted on top of it, the white and black one. And then we can see the umbilical sort of snaking around on the quayside. So this was before deployment. It's now been in the water for 12 months, and we're getting ready for decommissioning. So how do we get there? So this is just showing motion energies and volumes pathways. Focusing on motion, really this prototype Blue X was developed via the Wave Energy Scotland pre-commercial procurement program. This was a staged development approach, competitive stage gates that they were the prequel to the IEA OES international framework for scoring ocean energy technology that is now pretty mainstream and very positive that it is. And so this ultimately led to the build of Blue X and then an initial deployment in 2021, and then this deployment, as I say, in February 2023. I won't focus on these. There might be questions that are specific to the subsystems, but this is a 10 kilowatt rated WEC. It's about 20 meters long. The subsea storage is fairly small, it's about 50 kilowatt hours, and that's just due to the budget available for this system. And then we've got an umbilical with a slip ring and a swivel that allows the WEC to weather vane, align itself with the predominant wave direction, and the skid is on the seabed. So fly through this. So RSP itself built on the first deployment at Scapa Flow that we did in 2021. Again, that was part of the WES program, and that was an initial sort of wetting our feet, so to speak, and getting Blue X in the water for the first time. So you can see there's actually no solar panels for this initial deployment. We were just dumping power. We weren't connected to anything, but it was really important to prove operations at sea, begin to prove the comms reliability, the reliability of the general system, and making sure that everything was working as it should. So as you can see, the conversion philosophy of this device is really just the relative pitch of the two hulls when the WEC is excited by the incoming waves. And even in this relatively benign sea state, Scapa Flow is a relatively non-exposed site. We got some good sort of 5 kilowatts sustained power and peaks up to 30 kilowatts. Then the rated power of WEC is a bit ambiguous, and I won't dive into it just now. But really a key thing to highlight is that Blue X was the result of this stage gated approach that has now been taken up by other programs like Europe Wave, for example, and Motion is involved there with the next size up machine, which is a 250 kilowatt device. This is another video from the comms mast, so looking out to the front of the device and just showing how part of the survival philosophy is to be able to passively dive under the steeper waves. So shedding the extreme hydrodynamic loads by avoiding wave slamming and just ducking under the steeper waves. The use cases, so in an off-grid sense, I prefer to use the term demand markets instead of niche markets, because some of these are really significant in size, but the three drivers here really are decarbonization, electrification, and the economics, of course. So across these domains that we see summarized on this slide, really wave energy acts as an enabler. So an enabler of getting power in situ from a renewable source. And this is about increasing energy security, getting rid of long, expensive umbilicals, reducing reliance on large vessels that require crew and obviously have associated emissions. And just the market for subsea umbilicals is about £1.9 billion globally. So these are big markets. CCS is obviously coming up as well. So just to give you a sense of what data, what our dashboard for the WEC looks like, took this from the 13th of February, so it's relatively up to date, so this year. And this is really going from the the beginning of the deployment when we kind of switched on all the systems. So the overall energy generated was almost, I think, is now very close to 10 megawatt hours. The first trace at the top is the hinge encoder, so the relative hinge angles, and we can see that they stay pretty much within the 50-degree mark. The overall range is, if I'm not wrong, -90 to +110 on BlueX. So well within sort of our limits. We don't need to rely on the end stops, although they're there just in case. Then we've got the power generated in the middle and exported. So part of the learning was the blue traces you see there is power that is dumped. And that means once the subsea battery is full, max capacity, we're then dumping the power. So you can see much more power generated in red sort of early on when it was sort of the back end of winter and spring, then a bit of a lull across the summer months, and then again really generating a lot of power over the recent winter. And October was the time when we saw the most extreme waves, and there'll be a video of that. The aim of the game really is that we have a variable wave power availability and resource, but the goal is to transform that into consistent power delivery. And so the energy storage is something that the solar system is also helping that, and we're looking to expand that. The commercial version of BlueX, which will be called Blue Star, which we're very close to commercializing. This is a view of the halo, just here for reference. I can't really talk you through it anyway, even if I had time, but I just thought it would be interesting to see what we're monitoring. I'll skip through this as well. This is just showing some footage from the subsea, the AUV. So this is the subsea skid, and several sort of monitoring missions that we did with the AUV just to prove out the monitoring of the subsea systems. But it's interesting to sort of get the subsea view as well as from the above the water view. And then obviously docking and undocking was part of you see some marine growth and the reference points for the AUV and the dock. Some highlights. So I think I've spoken to some of these already. Really good comms availability, which was a key metric. Some really impressive solar yields given how small these solar panels are. The front two are getting quite a lot of biofouling on them as well. The ones on top of the nacelle have stayed surprisingly clean. We encountered maximum 7-meter significant wave heights. That was in October in Storm Babette. This is some footage from that, but we kept operating and exporting power, which was excellent. Didn't suffer any failures, and you can see it was pretty aggressive. So here you're seeing IP camera that's facing backwards, so the tail of the machine moving, yeah, quite a bit here. So 7-meter significant wave height, so maximum wave heights as much as double that value. So I'm just wrapping up here, just the final couple of slides. What are the next steps? So firstly is about rollout of these small scale systems. So when I say small scale, I mean sort of off-grid in the tens of kilowatts. So this will be the Blue Star. To do that, we sort of have a bottom-up and a top-down approach. So the bottom-up is about extending potentially RSP to longer than 12 months. We've decommissioned the machine and we need to inspect and make some upgrades. And then we hope to take it to an actual operator site. And then there's some top-down policy push, which is really encouraging. And this is coming from the North Sea Transition Authority. And we hope this continues. So this is about setting more stringent conditions on new and existing oil and gas licenses and trying to incentivize the use of renewables there to decarbonize and electrify. The final slide, so scaling up. This is also a key part of the next step. So we're involved in Europewave, and here we're trying to build a first of a kind 250 kilowatt machine. This does have some off-grid uses and CCS and aquaculture, for example. Ultimately, this is a precursor to grid systems, and this builds on RSP. And as Lotta was saying, RSP and off-grid can be a really useful stepping stone to grid. So again, RSP model has given us this sort of integrated industry partner consortium approach that we're looking to take into the Blue Horizon Europewave program to complement the public funding that we have. And then finally, obviously the policy seascape is really key to enabling the next phases. And one thing I want to mention is that any win in this industry is a win for the whole industry. So we need to keep building. I think we are building momentum. We're seeing growing traction commercially. And so we need to keep our foot on the gas, so to speak. Or I don't know, board on the waves, maybe is a better analogy for surfing. So yeah, thanks very much. Sorry, I went over time. Happy to take questions at the end. Thanks, Lotte.
Thanks, Andrea. That's really interesting, especially to see the power production that you showed. I think we had one question specifically for you on the slide where you had the different use cases. So based on the different use cases, are different KPIs calculated and presented?
Yeah, that's a really good one. So I guess the first KPI that comes to mind always with any energy project is LCOE. So in these cases, part of the enabling element of going to off-grid is that LCOE is much less of a driver, and we are competing. For example, if you're replacing, in the case of tiebacks, so when you're trying to bring power to a field or to a set of sensors offshore, really the only way to bring renewable energy tends to be either from shore or from the nearest host platform. And that means tens of kilometers of cable that you need to install. You need to trench that. And then that's also lost. So once it's down there, you can't retrieve it, or if you do, you can't reuse it. So it's kind of a lost cost. And that's, millions per kilometer. So if you can put a wave energy converter type system that is standalone nearby where you need the energy, that's a relatively easy win. Of course, there's the perceived risk element that is part of the equation. So it's not as much of a slam dunk as you might assume. But it's a very different KPI to one that you would have on islands or grid.
Okay, thanks for that. We will probably have more questions for you after the other presentations, but for now, I think we can move on to Michael. So let's continue with the wave sector. Michael from Wave Piston, the floor is yours.
Okay. Thank you, Lotte. Can you see the screen here?
Yes.
So, it's okay?
Yes, it's good.
Okay, well, thanks, Lotte. So those of you who don't know me, I'm Michael Henriksen. I'm the CEO and co-founder of Wave Piston. Wave Piston, where we've actually been going on now for 10 years. So I'm going to tell you about Wave Piston and our focus on these sort of large grid marketing. So first of all, a bit about the technology. For those who don't know, it's like we call it a string. We have these vertical sails in the sea, and then just below the surface, as the wave passes by, these sails are pushed back and forth. They drive pumps that suck in seawater, increase the pressure to high pressure seawater, so it's a hydraulic system, and then push to valves. So this high pressure seawater from each of these modules going to the common pipe, and then from several strings that could be next to each other here in a wave farm, they all go into a conversion station. And this conversion station could be offshore on a platform or onshore. And there you can use it for two things. On the right, it's power production via standard Pelton turbine, so it's a hydropower. That's hydropower, so it's normal power to grid. And then we have on the left, then it's for use for desalination, because high pressure seawater is what we use in reverse osmosis system to desalinate the seawater. So we have we can get two end products. One is electricity, the other is water. One and the other are both at the same time. Okay, so what we see is on these markets is actually what we have this stepwise approach, a bit also what Lotte talked about in the beginning. We said we start with these smaller. There are still multiple euro markets, but that's for off-grid, high-end consumers, but also desalination plants, getting the smaller installation from 2 to 50 megawatt. We say getting that out, starting with that, because there are many of these places with islands and coastal communities have very high energy prices, and many also lack fresh water. So that's where we start. And once we start scaling, get the unit cost down, and are we into the market, then of course this utility scale market opens up. So this is sort of this very fast on our go-to-market strategy. And what are we doing right now, which is the interesting part, of course, that is our ongoing full-scale test and demonstration in Gran Canaria, just off the east coast of Gran Canaria, in the Plocan test site. And there they have this platform at Plocan, the test site, which we use as an energy island, you could call it. And then we have placed our string, so one string, one wave energy converter, where we can place all these energy collectors on. We have slots, we have 20 slots available that we use for testing and demonstrating at full scale. And then we have a pipe that goes up to this platform where we have the conversion station. So what have we, by now we have installed the whole string and everything, and we're putting up energy collectors. And on the platform here, we have this turbine generator. So it's like it's containerized. You have the power generation here below, and you have the desalination above. And then we have a valve that controls how much goes to one or the other. And just to show schematically to make it clear, so we can just go to the turbine generator power. We have the valve, so it's a turbine that actually controls the pressure. There's a nozzle in the turbine. Then we have valve controls, it goes into a high pressure pre-filter and into a reverse osmosis system. We've not installed the post-treatment because all this is standard stuff to post-treat a reverse osmosis system. So that's what we're doing. We're just desalinating and getting out again. It's not going. What we also could do is, of course, in our system, there's only a pressure loss around 3 to 4 bars. So there's a lot of energy still in the water. So in this high pressure water, that can be reused in the RO system or going to a turbine for recovery. And what we have right now, we have installed this test string I was showing you before. It's ready there. It's been there since last year. We'll finish everything was December. And then we have had these babies, that's the energy collectors that have been assembled in the port. The first one has been installed. It was installed 8th of February to get the first experience with energy collectors on the string to test what is working, what's not working. So we have cameras on this. And then based on that, we have 6 more energy collectors that we can upgrade and we can put on the system. And then we've done that, and we'll start the power production and the desalination unit afterwards. But that is what we're going to do now during 24. Show these, test it, demonstrate results on this full scale. And then we're in parallel working on these first commercial pilots, we call them. That is to start the commercialization journey and then before we go into scaling and the utility side. Just as an example, we put this up. That's one of the projects we're working on is off the coast of Gran Canaria. It's actually just next to a desalination plant because what we think is good to do in the first stage, that is having these first commercial pilots. We are part of a consortium around this, so we have a good consultant there. And then getting the first smaller scale solutions out. This is a 2.7 megawatt solution where we have everything from the energy converters out here, a small farm, power to sort of a high pressure seaboard to shore. And there we can actually have the possibility of just convert it to power, or we can also use for desalination. These are some of the ones, sort of the pilot projects we're working right now in parallel to finishing and showing the results from our full-scale demonstration system. And I don't have more beautiful data or pictures like Ocean Andrea had. It was very nice to see that. I hope we'll soon come with that when we have our all the energy workers on our system and can show the results for that. That was a bit faster. Any questions we take now or later?
Thanks. I have a question. I mean, how much fresh water could you produce, for example, with the demo project that you just showed?
The one we just showed, we just have if you remember the desalination, the reverse unit. There's only one membrane coming in. If I recall it correctly, it's scaled for around 28,000 cubic meters per year. I think it's around 100 cubic meters per day. So this is only for, you can say, for demonstrating. So it's around I think it's around 20 20% of the energy we could actually produce, because it could be energy or it could be water or desalinated water. So we're using around 20% of the capacity, given that we have a full string out. So in the end, of course, it will depend on the wave climate and then the number of strings that we put out.
Okay, thanks. I just saw a question here for you. Is the desalination process taking place inland?
Well, it has to be in a dry location. So it could be on a platform, could be inland. But if it's on a platform, of course, we need to get the fresh water via pipe to shore. So you can see these special locations, the islands, coastal communities, many of these locations that we can actually be relatively close to shore, because most of our solutions, also our partners here, that we don't spoil the view, you can't see the system really, so we can be relatively close to shore and getting the high pressure seawater to shore within a few kilometers from shore. So then the conversion, so the desalination part, will happen onshore. But it is possible, of course, also to do offshore, but then you need a low pressure pipe to get the water into shore. Or if it's power, then of course a cable.
Okay, thank you. I see some other questions coming in, but we'll take them after the last presentation. Also questions that are relevant for all speakers, I think. So we'll take them after Brendan. So Brendan, now we're looking at the tidal sector, or PC or tidal or river power. So you are working on powering remote communities, the floor resource, and we can already see your slides. So perfect.
Thanks, Lotta. Yeah, as Lotta said, with RPC, we're looking at a number of applications for off-grid solutions using marine renewable energy, but I'm going to particularly focus on the work we're doing around remote communities in this presentation. So just a bit about RPC first. We're headquartered in the United States, in Portland, Maine, but we also have teams in Canada, Chile, and Ireland, where I'm based. So our focus is on capturing the energy in free-flowing rivers and tides using our proprietary cross-flow turbine system, which you see in this photo, and which is common across the various power systems we are developing. And it's really, we've had a strong focus on applications in remote communities across the multiple projects we've deployed over many years now. Just sharing some of those that are active at the moment. Currently, we're developing, a number of different product lines with deployments planned for these across North America, South America, and also Europe later this year. And I'll touch on some of these in the presentation. So why are we targeting remote communities and wider off-grid applications? Just some points here that I thought are kind of really pertinent to this discussion. So while we talk about it, and Andrea going to reference this as well, it's not necessarily a niche market. This can be still quite a large market, and Michael had also addressed this. At the moment, there's, it's estimated by the UN that nearly 700 million people worldwide are without power or reliant on diesel generators, and other studies have assessed that there could be up to 2 billion people who's are reliant on poor or unreliable connections, and because of that, their economic development and their livelihoods are quite constrained. So there's a lot of people around the world that are looking for solutions to support their electrification. Secondly, then marine renewable energy systems have quite a high value proposition in this area, and can also be very cost competitive. So in the case of off-grid communities, often you're competing with diesel generators, and in some locations, particularly remote locations, that the cost of that power, as well as some of the other challenges around it, can be quite large. So you can start to compete potentially at an earlier stage in your commercialization pathway, which is very attractive. And then also the generating profile of marine renewable energy systems, particularly river and tidal energy systems, which are quite predictable or stable, that has a very high value, particularly if you're looking at microgrid situations where you want to reduce the capex that can be associated with over-designing or over-installing the amount of storage or intermittent renewable energy capacity you need. bringing in a very predictable, reliable source of renewable energy can be quite valuable, and reduce the amount of storage you need. And then finally, in terms of impact, the impact for these projects can be very high, be it in terms of reducing CO2 emissions or emissions of other chemicals that can be very harmful to human health. Obviously, the impact of electrification in remote communities can be very valuable, can support wider local economic development. This can also come from supply chain development, and then there's wider societal benefits that are well proven around bringing clean electricity to remote communities. So in the next section, I'm going to talk about some of the projects we're working on in these types of scenarios. I'm going to start with our flagship project, which is a river-based project with a village called Igiagig in Alaska. So Igiagig is about 400 kilometers from Anchorage. There's no road connection, so access to the village is by light aircraft or barges, which are quite seasonal because of ice coverage on the river. We've been working with the village of Igiagig for almost 10 years now to develop projects and deployments at this system, and our Igiagig hydrokinetic project has been active and installed since 2019. So we've been working with the village to reduce their reliance on diesel and transition to clean baseload power from the Kivak River. So we've had single devices installed since 2019, and as of September of 2023, we now have 2 units installed. So coupled with the smart microgrid system that's also installed as part of this project, we expect to reduce the village's diesel requirements by 60 to 90%. This is the overall structure we've developed, or this is the model we hope to, we're using in Igiagig, but hope to expand to other remote communities around the world. It's based around the combination of the baseload power source from our RivGen power systems, or it could be our other power systems in a tidal environment. It's coupled with smart energy controls, or smart microgrid controls, and energy storage systems. We've been working with Schneider Electric on this project, but also we've signed an MOU to look at the opportunity for expanding this microgrid, combined microgrid system across the world. And then this can integrate with other forms of renewable energy, such as wind or solar. It can relegate the diesel generators to backup only, and the whole system then can be grid forming to reduce that reliance on diesel. We're also, we have a device deployed in Canada, but we have another upcoming deployment in this type of setting in Chile, which is happening in the coming weeks. Here you can see the device leaving the fabrication facility in the US as part of that journey. And in Chile, we have a really exciting opportunity to work with the local municipality in the Chile Chico region and Patagonia as part of plans they have at decarbonizing their economy. And this was, including supporting electrification of communities without the need for expensive transmission line build out. Very similar to actually what Andrea was talking about in terms of tiebacks and the offshore environment. Here in a lot of remote communities, the opportunity is either to, expand the grid, which is very costly and can be time consuming and has a lot of risk, but potentially you can skip that step and move to this microgrid type of arrangement for remote communities and save a lot of that heavy infrastructure development. But it's also looking at other applications for renewable energy in an off-grid environment, including establishing electric vehicle charging points along the remote road network, which is in a very beautiful area that's ripe for tourism development. This can support the decarbonization of that industry also. But given this is an ETIP Ocean webinar, I also want to reference the work we're doing in a tidal environment. Over the past 10 years, we've been working with another community in Alaska, False Pass, which is in one of the Aleutian Islands. So over 10 years, we've been working with the city and also the National Renewable Energy Laboratory to evaluate the tidal resource on the island, but also to design a community scale microgrid that can be integrated, with tidal energy devices. You see here a single turbine version of our TiGen that was deployed in Maine last summer. And recently we've been able to secure additional funding to advance this project in 2024. So again, we're able to replicate the work we're doing in Igiugig, but in a tidal environment. And then just some other projects that are also kind of are in the off-grid market, but where we've also identified opportunities outside of remote communities. Another tidal project, again in Alaska, where we've a huge opportunity, is based around the port of Port Mackenzie in Cook Inlet, a very high tidal flow location. And here we're looking at deploying our RivGen in a tidal environment to power the cathodic protection system in the port to support the anti-corrosion measures that they have in place. And then separately, in pivoting back to a river-based project, where we're working with Shell's Marine Renewable Energy Program to deploy 2 of our modular RivGen systems in the lower Mississippi later this year, which is also looking at off-grid applications and use cases for river energy systems. So to wrap up, I'm just going to touch on some of the learnings ORPC has had as we've worked with remote communities over the last decade. Firstly, and going back to that point I started with around impact, so through some research we've done with Queen's University Belfast and Letterkenny Institute of Technology in Ireland, we've been able to do a life cycle analysis of the project at Igiugig, and this has shown some really positive results in terms of the overall CO2 reduction from the project. And again, bearing in mind here, we're displacing heavily polluting diesel that's also transported by barges and light aircraft. So the transport aspect of that is quite significant, and we've shown here a 98% reduction across the 20-year lifetime of that project, and also significant savings in the quantity of diesel that the community would have needed to have purchased and used otherwise. So again, very strong impact, and you can imagine as we scale these applications worldwide, going back to that large market size in terms of the climate impact for decarbonizing these opportunities, these remote communities, it is very significant. We've also, I suppose, learned a lot from a technology development perspective. Our RivGen system, for example, has been really the design of that has been iterated and developed with remote communities in mind. So it's easy to install, easy to transport to these locations using standard trucks and barges. We can assemble it without the need for specialist equipment. We just use local construction vehicles like excavators you see here. We can install it because it's on these pontoons in using local fishing vessels. So again, we're eliminating the need for specialist vessels. And we've also really leaned on local supply chain and local workforce in many of these activities. So we can install this with small teams, a minimum amount of ORPC staff, but really working with local contractors to deliver these projects in a very successful way. And then finally, a really important part of this and a very strong part of our company's overall ethos as well is around stakeholder engagement and community partnership. I think the model we've developed in Igiugig has been hugely valuable for us. Partnering with a really visionary community who have, been the first tribal entity in the US to secure a FERC license. They're the license holders for this project. We've been really lucky to partner with them. They've have so much local knowledge and expertise around the river, around the operating conditions, and we've been able to leverage that in the project delivery. Without it, we'd be the learning curve for us would have been much steeper. But that sense of partnership and the two-way flow of information has been very valuable as we've delivered this project. And I think that's something we will continue to seek and strive for in future projects that we develop. So I'll finish there, Lotte, but happy to take any questions now or as part of the panel discussion.
Thank you, Brendan. I'm really happy that you brought up that community engagement topic as well, because I think in many, let's say, off-grid applications, that's an important point, because if you're working with remote communities or islands, you need to take that into account and really work with the community as well. Good. I would invite all the panelists to come on stage now, and we can start the discussion. I see that questions are coming in. I would like to hear your thoughts about on what I think all of you, in fact, touched upon, on whether all these, and actually I wanted to say that we don't call them niche applications, because I agree with what you said. It's not that niche. That's why we called it the off-grid. I think it kind of encompasses the message in some way. But can these applications that you've been developing be directly replicated at utility scale? Is that the stepping stone, or are these two different streams of development? If you think of going to the large scale farms compared to these kind of off-grid applications. And while we will discuss with the panelists, I would also like to hear if any of the participants here have an opinion on that. So feel free to put that in the Q&A and I will then read that out loud. But any thoughts on, is this the necessary stepping stone, or are these two different streams, development streams? Michael, I see you want to jump in, so I'll let you start.
Yeah, that's one thing. I think it depends a bit on the technology. From our side, it's definitely, we see it as a stepping stone, because we have this energy collector which is on a string, and it's a number of units. We see this as, you can say, properly speaking, it's like a solar panel. We are building one solar panel, and it's just a number of units that we put out there. And of course, what our limiting factor is of the distance to the conversion station. And if they're large enough, then we need to have several conversion stations. But definitely, this is a stepping stone in our strategy. As a start with that we can go in, we can also be competitive, and they are very interesting markets also from a commercial point of view, and that's a stepping stone into the larger ones also. It's not that we gotta leave the other ones, because they're both interesting, but it's just there'll be an extra large markets in the next step.
All right, thank you. Who wants to?
Yeah, I can jump in as well. I think for us, it's maybe a bit of both. So I think we would, we've developed multiple product lines at RPC, but they're all based on the same common components around the turbine, the generator, the foils. So I suppose by initially developing the remote community opportunities, we're commercializing one particular product line, but the feedback we get for the, let's say, the larger scale applications is very valuable. And we're starting to see that now. As I showed initially, we've multiple projects in development, so we're starting to realize your supply chain benefits as we place larger orders with suppliers, for example, and reduce tooling costs. So that does have a positive impact into our larger scale projects as well. But certainly, I think some aspects of the remote community project are quite fixed for that market application and maybe don't scale as easily.
Okay, thanks, Andrea.
Yeah, there's not a lot to add, perhaps. I mean, I think it is a bit of both, and even in the sort of off-grid or demand markets, there's quite a bit of variety. So I would say there's two elements. There's sort of the technology, and then there's if we look at the technology as the outcome, and then the process of developing a project and developing the actual technology. So you've got the outcome and the process. The technology, the fundamental building blocks are the same, albeit obviously for utility you scale up either in number of machines or in the individual size of the machines themselves, which is what we plan to do at Motion. So there's a lot of overlap there. The process, I think, is the really important thing, because going to these demand markets where you can get away with smaller size machines and, let's say, cheaper capex, gives you the opportunity to learn by doing. So to go through the process, which will have its differences, because if you're deploying in an island or a remote community, there's a huge amount of work. And I don't have direct experience. I have an initial insight from going to an island community in Chile a couple of weeks ago, but Brendan and Michael will be able to speak to that. How much work is required in terms of the engagement and the project development aspects. But in terms of the process of developing the technology, going to a demand market gives you the chance to go through the full process. So from design to the trials to the actual operational, tie that off, get a bit of track record, get a bit of momentum behind you to then take that to other markets. And they could be across a different number of applications. But I think getting and recuperating some of that lost momentum that was lost in the past wave and tidal energy, wave especially, is really, really key. So that's kind of the approach that Motion has taken. I think that's probably motivated some of, you know, wave pistons and RPC's approaches as well. So yeah, it's not a clear answer, unfortunately. It's 50-50. But it definitely does help. It's not that it's a complete, I don't think it should be viewed as a completely different sort of satellite enterprise. I think it's very relevant to the utility grid push.
Exactly, yeah. I wasn't expecting for a clear answer, so worry.
It's good. I'm glad I haven't let you down then.
Great. I'll look at some of the questions that we have here. First of all, someone commented that if you're interested in offshore green hydrogen production, he linked an article, so I will put answer in live so that everybody should be able to see that if you're interested in that. Then we have a question on permits. So what type of permits do you need to get this type of device in this type of application, I guess? And this is to all of you. So really broad question, I know, but I don't know, let's start with Michael.
Well, so Brendan has more experience than I am, I guess, with all the. But I can tell you what we have been through. Of course, one thing is in the test area where we are now Flogan, which actually have been quite also a bit of a struggle also on the permission side. But we are there. We can use power to grid. We can also do the desalination, but we cannot go to the island grid because as soon as we do that, then another type of permission kicks in, and it's the same we're doing, etc., etc. So it's a bit at the moment. It depends on where you are in the world or which country you are in the world. It looks like we also had some experience with it in Denmark, but so that's a bit you can say frustrating because the processes and the procedures are not that streamlined and not ready for many of these offshore installations. But I think it's getting there. There's a lot of positive attention now. We have very large support from the local stakeholders, the local government. I think they want to do this, but at the same time, we need to talk with the national authorities about the different things. And then it both have, depending on which country, it can be, you know, it's port authorities, it's environmental authorities, it's the grid side, a lot of different authorities you need to get involved to get into the next stage where we are working on them over these pilot farms. But I think maybe Brendan has more experience with the specific installations that have been done.
Yeah, I think you kind of touched on a lot of it, Michael. You know, to some extent, it is very based on the jurisdiction you're operating in. I would say, you know, with off-grid applications, often it can be a bit more streamlined because you don't have the complexity of integrating into a wider grid system. So that certainly can be helpful. And again, it makes these types of opportunities attractive, you know, as an insertion point for these technologies. It does take away maybe some of the timelines of bringing a project to fruition and some of the risk around that, which is very helpful. I think another, you know, area of this that we've probably had a lot of experience is on the environmental permitting side of it. We've learned a huge amount about operating in Alaska in Igiugig. It's quite a sensitive location in terms of the local population of salmon, and we've had to, you know, we've done a lot of monitoring through the project, and we've developed an adaptive management system to, you know, identify upfront risk and stage process of monitoring, retire that risk, and ultimately, you know, reduce the amount of monitoring we need to do, because that can be potentially a very high overhead on, you know, what's a relatively small project compared to, you know, hundreds of megawatt offshore wind farm, for example. So that potentially could, you know, make a project very difficult. But having something like this adaptive management process, you know, and hopefully we can kind of expand that into other jurisdictions, does mean that you can you know, manage and retire that risk in a less burdensome way, while also, you know, obviously achieving the objective of demonstrating that you're having not having a negative impact on that operating environment.
Exactly, and I believe in Scotland they are using this sort of adaptive management, and they're usually the front runner, let's say, in permitting. So, Andrea, what's your experience on that?
Yeah, I guess I think what Brendan's saying about getting away from some of the grid complexities is really relevant. In the case of RSP, that site wasn't part of EMEC, so as ever, you have to get your lease and you have to get your license. So that's about engaging with Crown Estate Scotland and Marine Scotland. There's a consultation process. The environmental impact assessment wasn't the stringent sort of formal sort of 2-year process because of the limited deployment time, 12 months, and the relatively small deployment size. So that also helped. In the oil and gas space, which is some of the demand markets we're looking at, this is quite a new use case. So actually, we've been engaging quite a bit now with the North Sea Transition Authority to try and map out what that permission consenting process looks like, and what entities we have to sort of get approval from, and who has responsibility for what. It's unfortunately still a bit nebulous, and so this is an exercise that we're doing alongside them, that they have a stake in, but is not quite as straightforward as we initially perhaps thought or assumed. So again, I guess it relates back to what Michael was saying: different process in different geographical areas, different process in different applications. But there are certainly some advantages. The grid aspect is a big one.
Lovely. Thank you so much. I think we have to wrap it up here. There are a couple of more questions left unanswered. You can send those by email if you want to get answers to those, but we have to wrap up now. So thank you so much for participating, to all panelists and the attendees as well. This webinar was recorded, so all the presentations and the recording will be on the EgyptOcean website. And if you want to join the platform and receive further information on events or invitations to these webinars, you can join our mailing list on our website, egyptocean.eu. So with that, thanks again, everyone. I think that went really fast. I hope you all enjoyed it, and we will see you in the next webinar.
Thank you, Lotta. Thanks, everyone.
Thanks, everyone.
Take care.
Thanks, pleasure.